Hello my dear learners, welcome to NIUS Secondary Science and Technology classes. Myself Neha Kesharwani, HCO Chemistry. Today we will going to discuss about the chapter Carbon and its compounds. This is part 1. In this part we will going to discuss about definition of carbon, occurrence and classification of carbon compounds. So let's just discuss what are the topics which we will going to discuss today. The topics which we will going to discuss today are definition and occurrence of carbon, covalent bond and its types, bonding in carbon covalent bond, formation of covalent bond in different molecules. So the learning points are, after completing this part, you should able to understand what are carbon compounds. You can understand how covalent bonds are formed, how covalent bonds are different from other kind of bonds, and how many types of covalent bonds are there. Before starting this chapter, let's just discuss about carbon compounds. Carbon compounds are chemical substances that contain carbon atoms bonded to any other element. The majority of these molecules are organic carbon compounds, for example benzene, sucrose, etc. Although a large number of inorganic carbon compounds also exist, for example carbon dioxide. Next we will going to discuss about occurrence of carbon compounds, how carbon compounds are occur. Number 1, carbon is found in the atmosphere, inside the earth crust and in all living organisms. For example, if we talk about carbon dating, with the help of carbon dating we can identify the percentage of carbon, and with the help of percentage of carbon we can identify the dating of that particular compound. Carbon is found in the free state as diamond, graphite, fullerenes, etc. The example of fullerene is carbon 60 and more than carbon 60. Carbon is present in compounds like carbonates, hydrogen carbonates, etc. So the formula of carbonates are CO3 2-, and for hydrogen carbonate it is HCO3 2-. Carbon is present in fuel like wood, coal, charcoal, coke, petroleum, natural gas, biogas, Mars gas, etc. Here are some pictures. This is wood, coal, coke, charcoal, petroleum, natural gases and biogas, Mars gas, and the last one is the picture of diamond. So these are some sources of carbon from where carbon occurs. Carbon is forming covalent bond. Basically there are 3 kinds of bond: ionic bond, covalent bond and coordinate bond. Because carbon is present in p block, this is called p block element. That is the reason carbon form covalent bond. The another reason is carbon is a non-metal. So that is the another reason why carbon form covalent bond. So let's just discuss about covalent bond. A covalent bond consists of the mutual sharing of one or more pairs of electrons between 2 atoms. These electrons are simultaneously attracted by the 2 atomic nuclei. A covalent bond forms when the difference between the electronegativities of 2 atoms is too small for an electron transfer to occur to form ions. A covalent bond is formed between 2 non-metals that have similar electronegativities. Neither atom is strong enough to attract electrons from the other. For stabilization, they share their electrons from outer molecular orbit with others. An ionic bond is formed between a metal and non-metals. So as I said earlier, there are three kinds of bond: ionic bond, covalent bond and coordinate bond. In this chapter, we are going to discuss covalent bond in a brief manner. So let's just discuss about bonding in carbon, that is covalent bond. If we talk about covalent bond in carbon, the atomic number of carbon is 6, its electronic arrangement is 2,4. We know that carbon having atomic number 6, so the electronic configuration is 2 and 4. It has 4 valence electrons. Why? You can see here the last shell having 4 electrons, and the last shell of an element is also known as valence shell. It can attain stability by gaining 4 electrons, losing 4 electrons or sharing 4 electrons with other atoms. So by gaining of electrons or by losing of electrons, it will form ionic bond. That is not possible in this case. So carbon is basically sharing 4 electrons. It does not gain 4 electrons because it is difficult for the 6 protons to hold 10 electrons. So if we talk about carbon, the electronic configuration is 2 and 4. If it will lose or gain 4 electrons, on that case the total number of protons are 6. If it will gain 4 electrons, on that case the total number of electrons are 10. So if we talk about proton and electron ratio, that will be 6:10. So it is not possible. It does not lose 4 electrons because it needs a large amount of energy to lose 4 electrons. So that is not possible also. So it shares 4 electrons with other atoms to attain stability, resulting in the formation of covalent bonds. Since carbon atom needs 4 electrons to attain stability, its valency is 4 and it is tetravalent. So those compounds which having valency 4, they are called as tetravalent compounds. For example, methane. The formula for methane is CH4. So you can see the picture of methane here. Here you can see carbon is present at the center and 4 hydrogen are present as in 3D manner, where 2 hydrogens are in the plane, 1 hydrogen is above the plane and 1 hydrogen is placed below the plane, and this structure is known as tetravalent. So how this bond is formed? Carbon having 4 electrons in their last shell, so it will share 1 electron with all the 4 hydrogen atoms, and hydrogen also having 1 electron, so it will share 1 electrons from its side. And now you can see there are total 8 electrons in the valence shell of carbon. So now you can see carbon having 8 electrons in their valence shell. How? This is 2 to 4 to 6 and to 8. Now it having 8 electrons in their valence shell. Next we will going to discuss about formation of covalent bond in different compounds. Covalent bond is chemical bond formed by sharing of electrons between atoms. The sharing of one pair of electrons results in the formation of single covalent bond. Two pair of electrons results in the formation of double covalent bond, and sharing of three pair of electrons result in the formation of triple covalent bond. So in this manner, we can say that covalent bonds are of three types. Single covalent bonds where 1 electrons are shared, double covalent bonds where 2 electrons are shared, and triple covalent bond, in this case 3 electrons will be shared. As you can see on your screen, this is the example for single covalent bond. Formation of single covalent bond in hydrogen molecule. So how it will form? The atomic number of hydrogen is 1. Its electronic arrangement is 1. So hydrogen having only 1 electron in their shell. So we can say that the electronic configuration is 1 or 1s1. It has 1 valence electron. It needs 1 electron more to attain stability. So 2 hydrogen atoms share 1 electron of electrons, resulting in the formation of a single covalent bond in hydrogen molecule, that is H2. As you can see on your screen, this is one hydrogen and this is the another hydrogen. They get closer and they share their electron, and after sharing it will convert it into hydrogen molecule. So before making the bond, these are atoms, and after making the bond, known as hydrogen molecule, that is H2. In their valence shell they have 2 electrons, that is why they are stable. If we talk about hydrogen and helium, the octane value is 2. Why? Because hydrogen and helium having only s orbital. Our next example is formation of covalent bond in the case of oxygen. The atomic number of oxygen is 8. Its electronic configuration is 2, 6. It has 6 valence electron. It needs 2 electrons more to attain stability. So 2 oxygen atoms share 2 pairs of electrons, resulting in the formation of a double covalent bond in oxygen molecule, that is O2. So here you can see on your screen there are 2 atoms of oxygen. The symbol of oxygen is capital O and the atomic number for oxygen is 8. So the electronic configuration is 2 and 6, or we can say that the electronic configuration is 1s2, 2s2, 2p4. So they have 6 electrons in their valence shell. So for complete octet, it wants 2 more electrons. So for completing this, both the oxygen atoms forming covalent bond by the sharing of 2 electrons, these are shared pair electrons, and because they shared 2 electrons, that is why in between these 2 molecules there are double bond. So now we can say that this will convert it into oxygen molecules. So after making the covalent bond with the 2 electron, it will form double bond. Now we will going to discuss about triple bond. So formation of triple covalent bond in nitrogen molecule. So how it will form? The atomic number of nitrogen is 7. Its electronic configuration is 2, 5. It has 5 valence electron. It needs 3 electrons more to attain stability. So 2 nitrogen atoms share 3 pair of electrons, resulting in the formation of a triple covalent bond in nitrogen molecule, that is N2. So, the symbol for nitrogen is capital N. The atomic number of nitrogen is 7. So, we can say that the electronic configuration is 2 and 5, or 1s2, 2s2, 2p3. So, you can see that it have 5 electrons in their valence shell. So, for complete octet, it wants 8 minus 5, that is 3 more electrons. So, for completing their octet, it will share 3 electrons. This is the first atom of nitrogen and this is the second atom of nitrogen. It will share 3 electrons, and after sharing 3 electrons, they form triple bond. Why triple bond? Because it will share 3 electrons, that is why it will form triple bond. Now, it is known as nitrogen molecules. So, this is the example for triple bond. These are some another examples. This is the first example for hydrogen. In the case of hydrogen, the octane value is 2. So, first this is Ha and this is Hb. After sharing 1 electron, now this electron is the property for this hydrogen and this hydrogen also, and it will form hydrogen molecule, and now we can say that this hydrogen molecule is stable. This is the next example, fluorine. The atomic number of fluorine is 9 and the electronic configuration is 2 and 7. So, we can say that fluorine having 7 electron in their valence shell. So, for completing the octet, 8 minus 7, that is 1 electron it wants. So, fluorine shared 1 electron and form fluorine molecule, that is F2. This is the next example, oxygen and carbon atom. So, 1 carbon and 2 oxygen combine together to form double bond, and now we can say that the structure of carbon dioxide is C double bond O, double bond O. Next is the example of CF4, that is carbon tetrafluoride, where 1 carbon gets combined with 4 fluorine atom. This is first, this is second, this is third and this is 4, and after combining it will form CF4, that is carbon tetrafluoride. Now we are going to discuss about the electron dot structure of methane and ethane molecule. If we talk about the electron dot structure of methane and ethane, we know that carbon having 6 electron, so the electronic configuration is 2 and 4, and hydrogen having 1 electron in their last shell. So, this is the structure for CH4, where carbon atom having 4 electron in their valence shell, so it will share 4 electron with different 4 hydrogen atoms, and hydrogen having single electrons, so it will share, and after sharing you can see now carbon having 8 electrons and all the hydrogen having 2 electrons, and we can say that now in this structure all the elements are now stable. So, this is the tetrahedral structure for methane molecule. Next we will going to discuss about the structure of ethane molecule. You can see on your screen the formula for ethane, that means it having 2 carbon and 6 hydrogen. So, this is the structure, how carbon and hydrogen gets combined. The red dot showing the electrons of hydrogen and the blue dots are showing the electrons of carbon atom. So they gets combined to form this kind of structure. This is the structure of ethane, where all the hydrogen atoms combine with carbon with single bond. Why single bond? Because all the hydrogen and carbon share 1 electrons. Next we will going to discuss about a very important property of carbon, that is catenation property. Carbon forms a very large number of compounds. The number of carbon compounds is more than 3 million. It is more than the number of compounds formed by all other elements. This is because carbon atom can form bonds with other carbon atoms to form long chain, branched chains and closed ring. This property is called as catenation property. So these are some examples for carbon compound, like these are straight chain and branch chain and ring-like structure. Since the valency of carbon is 4, it can form bonds with other carbon atoms or with atoms of other elements like hydrogen, oxygen, nitrogen, halogens, etc. So this is about today's topic. In this video, we have been discussed about carbon compounds. Next, we have been discussed about the occurrence of carbon and its compounds. And lastly, we have been discussed about the properties of carbon compounds, that is most important property, catenation property. So thank you.